In example 1, we need to simplify the following expressions, and there's a few of these to do, so stick with me as we go through these. And just keep in mind that it just takes a while to get the hang of this normally, and the more you practice, the better you're going to be. I'm going to go through some different techniques that can work. With these first two, I think the technique we're going to use is change everything into sine and cosine. So what we can do here is we can change the cosecant into 1 over the sine. The variable here is alpha. It's just a stand-in for an angle. It could be beta or x or whatever. And then in the denominator, we're going to have 1 over the cosine. So when we work with this, as we bring this down, we can take the numerator fraction, write it down, and then multiply by the reciprocal of the denominator, which is cosine over 1. When we work with this, we get 1 times the cosine over the sine. And where possible, we should write this as one trigonometric function. So we're going to write this as the cotangent of alpha. Remember, cosine over sine, x over y, that's going to be the cotangent. This is the simplest form of the original expression. And again, the method that we used was try to change everything into sine and cosine. Let's try the same thing here on this one on the right. The tangent is sine, and that's a beta there. Kind of looks like a B, but it's got a little tail. It's a Greek letter. And then, so sine over cosine would be the tangent. The cosecant is 1 over the sine. You'll notice that we're multiplying, so it is allowable to cancel these out, or at least sine over sine is 1. And then we're left with 1 over the cosine of beta. This can be rewritten in a little bit simpler way as just the secant. Remember that the cosine and the secant have a reciprocal, relationship. So this one's just the secant of beta. We're going to switch now, and we're going to knock out C and D, and I think there's an E and an F. And I think we're going to use maybe a similar technique with this one. And I kind of, as you can tell, I like to start off with just try to change everything into sine and cosine. And if we can figure out something else that's a little bit of a shortcut through this whole thing, then we'll do it. But if we just look at the cotangent first, the cotangent is the cosine over the sine. Now we've got cosecant. Cosecant is 1 over sine, and theta is our variable here. So we now have a complex fraction. We're going to take the numerator, multiply by the reciprocal of the denominator. Sine over sine is 1. Cosine over 1 is just the cosine. So this one just worked out to be the cosine. Let's try the same technique with this other expression here. So we've got the sine of x, and it's useful sometimes to write that as over 1. Just as you would write 5 as 5 over 1, make sure that the sine is in the numerator. The cotangent is, oops, almost made a mistake there. That's the cosine over the sine. The secant is 1 over the cosine. Tangent is sine over cosine. Whew. The cosecant is 1 over the sine. We're multiplying all these together. There's no plus or minus signs in between these. So what we can do is we can cancel, or at least cross off things that are equal to 1. So sine over sine is 1. Cosine over cosine is 1. Sine over sine is 1. We're left with a 1 in the numerator. And then we're left with a cosine in the denominator. So remember, the reciprocal of cosine is the secant. And where possible, you should try to write this as just one trigonometric function. Alright, we'll move on to the next one. And I think again I'm going to try to change everything into cosine and sine here. That's often the first strategy I try to use. So let's see here, we've got sine over cosine, and we've got the sine of y over 1, just over 1, and then we've got the cosine over the sine. So now we can cancel these. We can cancel as long as we're in one term. Notice this plus sign. We don't want to cross cancel here, here, or here, or here. That wouldn't be appropriate. We do have the sine of y, and then here we've got plus the cosine of y. At this stage of the game, lots of people will try to change this into 1, but remember we need to have a little 2 up here. It's got to be sine squared plus cosine squared. It's not, so we can just keep it right here as is. Let's try to change the cotangent into, we'll go with cosine. It has to be that way. Cosine over sine for the cotangent. And then the tangent would be the sine over the cosine. Many people think this might be 1, or some people I should say, but unfortunately the cosine's in the top here and the sine's in the top there. So what we do need to do is investigate this a little bit further. We can take the numerator fraction, multiply it by the reciprocal of the denominator. We've got now cosine squared over sine squared. And so this is going to be cosine over sine all squared, which is just the cotangent squared. Now that might seem a little bit weird, and you can actually take a look at this in a different way as well. So there's lots of different ways to simplify these usually. Let me change the tangent into its reciprocal, which is the cotangent. Now we're going to take the numerator, gosh darn it, I'm writing the cosine down here, the cotangent, and multiply it by the reciprocal, and did it again. The cotangent, multiply it by the reciprocal of the denominator, which is the cotangent over 1. Of course, cotangent here is cotangent over 1. And so we still get the cotangent squared. You'll notice it took us a little bit longer to do that using sine and cosine, and this is maybe a little bit more elegant. It's just a 2, maybe 3 step simplification, but we arrive at the same thing.